Hi, everyone. Wanted to thank you all for joining us today on our SBT webinar series, this one looking at germicidal UV lighting, understanding the do's, don'ts, and the impact of UV lighting technologies. I'm Kevin Martin. I'm the VP of Marketing here at SBT Alliance. So thank you again for joining. Before we kick off today's webinar, I did want to take care of a couple housekeeping items, as with all webinars. The first item is really just a quick, disclaimer, right? Any information presented in the webinar is of advisory in nature. It's intended to be informational. Doesn't, imply any express or implied warranty. So please have a read of that, and we will continue the conversation. So today's webinar, if you haven't noticed, it is on the Zoom platform. During today's webinar, we will be having a few polls, and we will also be open for questions and answers. So when we launch a poll, a window will pop up on your screen. It'll have the options for the question. Simply select your answer, hit submit, and your response will be recorded. If you have a question, make sure you come down to the Q&A on the bottom of your screen, click that little icon, a new window will populate, and you can ask your question there. Today's speakers, we have two really great SBT folks on the webinar today. We have Shane Akernes, who is our Chief Strategy Officer. Shane is a 10-year veteran of the energy industry, and he has successfully operated one of the largest ESCOs in the industry, as well as launching a large-scale lighting company into the US market, and then managed it through to its eventual acquisition. Shane works with our SBT Fortune 500 clients, devising advanced IoT solutions that meet the specific needs of their businesses. We also have Jason Samuelian, who is our Director of Sales. Jason has a decade of design experience in crafting various solutions and applications from schools to airfields. He holds an LC from the National Council on Qualifications for Lighting Professionals, and he is also trained on AGI 32 and Dialux. So thank you both, guys, for joining us on today's conversation. Good stuff. So today's discussion, what are we really going to be looking at? There's really a few things that we really wanted to cover off on today's webinar. There's been a lot of webinars out there in the industry talking about germicidal UV and the different technologies, and we wanted to take a little bit of a different tack and really look at it from our perspective, right, from an IoT integrator perspective. So on a daily basis, Jason and Shane are out there working with clients, having phone calls with them on a daily basis. And we really want to just dive into some of those end user concerns. Why UV lighting? Well, why is it such a hot topic now? I'm sure many of you can guess why, but I'd like to explore that with them a little bit further. From there, we want to just do a quick overview of the germicidal UV lighting technology. We don't want to beat the drum too much here. I think everybody does understand the science of it. Following today's webinar, we're going to be sending out an appendix with a bunch of resources if you really want to get into the nitty-gritty of the science of it. But today we're going to cover the basics. And then lastly, we're going to jump into SBT Alliance's approach to deploying and controlling germicidal UV lighting. And the best way to really do that is through case study. So Shane is going to lead us through a discussion on a project that we worked on closely with a client and see how we approached it. Then at the end, we'll have questions. So please make sure that you book your questions throughout the webinar. There's a fair amount of people on today, so I will try to get to all of them. And if I don't, I will follow up following the webinar. So our first poll, I did want to launch this. So you should be able to see that on your screen now. Poll number one is really just looking at, have you worked with germicidal UV lighting before? There's a mix of folks on today's webinar. So if you're an end user, an installer, electrical contractor, let us know if you worked on with it or not. And we have some responses coming in. All right, great. Looks like about 70% of you guys have not worked with it before. So good. Hopefully there'll be some really good information in here. The next thing I wanted to do is really kind of just, open up this discussion. We've talked about this a lot from SBT Alliance's perspective in our contact tracing webinar, but, it's still applicable here, right? COVID-19 has really ushered in a whole new world of unknowns for businesses of all sizes, right? It's forced owners and facility managers to really muster the creative juices to seek innovations that will allow them to reopen offices safely and effectively. And at the end of the day, while there's no shortage of products and technologies, and understanding all of those capabilities is really one part of the equation, The other half of that is, really having an integration plan, because that's a whole new ballgame. And with that, that's what we really want to try to tackle in today's webinar. So before we do that, I wanted to open up the conversation to Jason and to Shane. Understanding those end user concerns that you guys have uncovered. So with that, I'll kind of open it up to you, Shane.
Great, thanks so much, Kevin. I can tell you that it's a different space we're in today, working with lighting and advanced controls projects. Our customers are concerned for themselves, for their families, for their coworkers, for their businesses, and there's definitely a new normal. So discussing the prevention of the spread of COVID is just a new normal in almost every conversation. And one of the things I found is we just really need to have an empathetic response. And with COVID-19 inquiries and self-reported cases, plus we really need to help the customer with education and how they can minimize that spread. They're getting information from a lot of places. And that leads us right into mitigation. In regards to mitigation, it's important to be able to identify, notify, and monitor people who are exposed to COVID-19 using contact tracing and other proven tools that we have available to us to speed the collaboration that's going to be required for us to work as a team with our customer base to come up with a solution. And then lastly, but definitely extremely important, protection. And maybe that's where we could provide, even the most amount of value by helping our customers contain the spread of COVID and reducing the strain on these employers. And in addition to, that protection measure, where we'll get into here in just a little bit with a case study of how that's done. It has to be done very thoughtfully, and it has to be done with a high level of engineering. And we quickly realized that a simple project, let's just say, putting some technology in place that reduces the spread of COVID-19 could have a lot of unforeseen issues that we could account for with the utilization of advanced controls to make sure that protection is maintained over a long period of time. And Jason?
Yeah, and building on that, I mean, the major concerns that I've seen from an end user perspective has been the cost of these products. I mean, obviously, if you had looked for this a year ago, they were out there. The products did exist, but I will say that over the last 6 months, the cost has exponentially increased. Not only is the cost of the product there, but there's also additional costs now on the energy consumption. You are looking at running these lights or these systems around the high peak demand hours, so you are looking at increasing some of your operating expenses. You're looking at increased maintenance costs, so the ongoing maintenance to make sure that these products are being effective and that they're correctly operating in a system. It definitely increased maintenance cost, and how do you even know when these products are out? So understanding that, do you throw a guy up on a ladder to go check all these products all the time? How do you know that they're working effectively? And then effectiveness in general. Since UV light is a non-visible light source, you turn on a product, and a lot of the products out there do include some blue spectrum light into it, just so that you know that it's on, or purple spectrum even. They do include that, but how do you know that the light is actually doing what it's supposed to do? So there's those three things that I think people, especially end users, are very, very concerned about. It sounds great. The science is sound. It's been around for over 80 years. and being used in situations of high infection areas all over the world. But how do we get this done in a cost-effective manner is really is really the biggest, I think, concern from the end users I've spoken with.
Yeah, no, and I think that makes a lot of sense from both of your perspectives, right? And I think there's a myriad of challenges and unknowns that a lot of end users really just, they're not familiar with. And that really, brings us to, poll number two, for you guys in the audience, as a system end user or an installer, what is your greatest concern in relation to germicidal UV? And, it's a multiple choice question, so you can rank it and, we can take a look there because I feel, there's challenges from an end user perspective, right? Somebody that actually owns and operates an office building or a manufacturing facility, to an electrical contractor who is working with a client that is, concerned about these things. Like, how do they navigate it? So I think there's a lot of things, that are of concern. And in the poll, I mean, it looks like effectiveness is kind of a big thing. About 71% of the respondents, 75% of the respondents, that's their biggest concern is effectiveness. So yeah, no, it's very, very interesting. And, speaking of effectiveness and germicidal UV lighting, let's take a look at the basics, right? So Jason, if you want to kind of give us an overview of, what does it really entail? And yeah, let's kick it off with that.
So this is not going, for those of you who have been on other seminars, this is not going to be the 4-hour IES seminar discussion about all the science. Basically, the most basic version of it is we are generally talking about UVC lighting when we talk about irradiating the virus or bacteria or whatever. But we generally will be talking about UVC. We will be talking a little bit about UVB and UVA, but let me kind of walk through that a little bit. As you can see in the in the chart, the farther we get away from the red end of the spectrum, the far UV light becomes the area where we are able to irradiate most effectively viruses. And so you can see in the picture below, what UVC light does to a virus is it actually disrupts the DNA structure. It disrupts the RNA actually inside of the structure, breaking that ability for that virus to effectively replicate. So the virus isn't dead. You may walk into a space of irradiated virus that has been treated by UVC lighting, and you may breathe that in. The big difference is that inside of your system, that virus is no longer able to replicate. And that's the big distinction. UVB is very, very effective. UVB and UVA are very, very effective at killing off bacteria or irradiating, again, breaking that DNA structure, irradiating the DNA structure of bacteria and molds. But UVC really is the most effective for irradiating the viral structure to prevent the replication of the virus. And that's really the key. Is we're not talking about killing off the virus. We're not talking about capturing the virus. We will be talking about some of those strategies later on, but primarily what we're talking about is that cutting off the ability to replicate. Now, what are the problems there? It sounds great. That sounds awesome. Well, as you can see on the chart on the right, provided by the IES, Eliminating Engineering Society, there are inherent dangers with working with UV light. And in fact, if you look at a spec sheet from manufacturers, you will see that there are very, very clear warnings about working with UVC lighting in particular. Photokeratitis is basically, if you've been exposed to UVC light for too long, you can actually burn the cornea of your eye. Basically, like snow blindness is a photokeratitis. So you can be exposed to it for too long. That can actually lead to cataracts if you are exposed to it over multiple periods of time. For too long, you can actually start damaging the outer lens of your eye. It can cause sunburn, erythema, and thermal skin burns as well with the UVB and UVA light. So prolonged exposure to UVC or any exposure to UVC in a direct light source is not recommended. And so some of the strategies that we'll be talking about talk about a lot of indirect exposure to the UVC. And actually that leads us to the next slide, where we talk about the different types of treatment. So the three major areas that we're concerned about when we're talking about and utilizing UV light to treat our environments is, one, we're talking about surface sanitation. Two, airborne sanitation, and what we'll talk a little bit about what that means, and then a combination of air and surface combined together. So when we talk about direct surface sanitation, this is where you will probably see a lot of the stuff, like where you may have read about the Metro MTA in New York is treating all of the subways, right, with UV light. Well, how are they doing that? Well, they are literally rolling in giant UV treatments, as you can see in the bottom left-hand corner, where they will roll that in with trained professionals. They will turn on the system for a period of time to treat the space, and then it will, anywhere that light source touches in a direct amount of distance and time, will actually irradiate the virus and make it inert. It will cause it to be inert. That's fantastic when you have the labor, the time to be able to do that for larger periods of time. There are other systems that Shane will talk about that we have been in partnership with to provide that direct surface cleansing. Then when we talk about airborne is a little bit easier, but it does require some stuff. So both the bottom right and the upper right are more treatment of airborne virus or bacteria or mold. And basically, those systems do require air movement, though. And that is a hugely important part of this airborne treatment, especially when virus has been aerosolized or when we're talking about particulate out of someone's mouth or whatever. So you do have to circulate that air in order for the light to be able to treat it. The UVGI HVAC systems, it treats it both before and after the coil. There's lots of different reasons why one is more effective for certain applications than others. But upper room UVGI has been used throughout the world, especially in the developing world, where you have more infectious diseases in more concentrated areas, especially around hospitals and treatment centers. A lot of study has been done about upper room UVGI in India when they've had tuberculosis outbreaks. Highly infectious, obviously, when it's been airborne, but very, very effective when you're talking about reducing the amount of viral load in a space. And then the last one is probably the most new system, where we're using a combination of systems, where we're talking about utilization of UV light, both UVA, B, and C, and also HEPA or charcoal filters inside of a contained space. So basically, what you can see on the upper left-hand corner is a light source that is just providing light to the space. That has nothing to do with treatment. It may have some UVB or UVA light in it, but it will be a minimalized amount. The real key is the fan system that's pulling the air in and then treating that air as it goes through a channel. It is being dosed with the correct amount UVC light to be able to irradiate a percentage of the viral strains that are inside of the system. Ergo, it's treating that. It also, at the same time, has the HEPA filtering for your bacteria and your molds to reduce some more of that common infectious things that can be bad for you as well, especially when we're talking about respiratory viral conditions. So those are our four main topics that we're going to focus on. Today we're mostly going to talk about on direct light sources and UVA, UVC, or UVA, UV, and air filter systems. And I think that's where I'll turn it back over to Shane.
Hey, thanks.
Oh, I'm sorry. We did want to talk about dosing. So this is really, really important. before I turn it over to Shane, we wanted to talk about dosing of a system. So you go to the doctor, you're sick, and the doctor prescribes you medicine. Well, he gives you a specific dose to treat the sickness that you have. If you decide to underdose yourself, you potentially are exposing yourself to more risk by not correctly dosing that disease that you might have. The same thing happens with UV lighting. If you go on Amazon and buy a UV light and throw it in your space and don't take the time to correctly dose the amount of light needed in your space, and then you're saying, hey, we put in a UV light, we're 100% good, we're good, we've reduced our risk factors, well, that may not be correct at all. You may have incorrectly dosed your space with either too much or too little light to be able to correctly irradiate your what you're trying to do. And it's based on two things. One, it's based on the intensity of the light source, and three things. Intensity of the light source, exposure time of that light source to a surface or an environment, and then three, the amount of distance from the light source to the treatment area. And as you can see on the two different charts on the right, bacterias can be treated for different stuff, for different dosages. And again, these dosages are in microwatts per meter. And actually they include time in the upper one. And then the bottom one includes distance. So the closer you are to a source, the lower amount of time that you need to dose that space. But again, when we're talking about this, we really need to think about, and this is really, really pertinent to what Shane is going to present on, we need to think about how much time will we have in our environment to be actually able to effectively dose the space. In certain environments, it might be unoccupied most of the time. So doing direct UVC light is an awesome idea. You can throw it into a space, you can leave it running for a long period of time, a smaller light source that can expose a lot longer period of time. However, if you're under very, very tight time constraints, you probably will have to dramatically increase the amount of UVC to properly dose a space. And that is where I want to turn it back over to you.
No, that's perfect. That's perfect. Thank you, Jason, for that. And I think that does, there's a lot of considerations to think about and think through when we're dealing with germicidal UV lighting, right? Or germicidal UV technologies, period. And it leaves kind of this lingering question of, well, okay, we understand that it can be effective. There's a whole bunch of science behind it, but the big question is, how do you safely and effectively deploy and control UV technologies, right? And and I think that's really at the heart of SBT's approach. And we really felt that there's really no other way to better illustrate that than to talk through a case study, right? And this is where Shane's going to come in and provide us with a case study of a customer coming to SBT and having some concerns, right? Having concerns about prevention and mitigation and protection against COVID mainly, but it opens up the door to a lot of different things. And Shane's going to break down this investment grade audit and sanitation lighting solution that SBT has put together, and it was really broken down into 4 sections, right? The first one is providing a little bit of a background on the project, what is the kind of space, and what were some of the concerns. And the second piece is really the product overview, right? One of the unique things about SBT Alliance, which I think most of the attendees, may know this already, is we're agnostic, right? We have a whole IoT ecosystem of partners that we work with, right? We're not just a one set, type of solution. We're committed to finding the best technologies and the best devices to provide a solution for the client. So Shane will walk through some of the products that we used on this particular project. And then from there, we're going to look at how some of those products were implemented in different areas within the facility. And then we'll talk through some of the commissioning and service. So, with that, I'll turn this over to Shane to take us through the background.
Great. So thanks so much. I had one of our longtime customers approach me and really have a heart-to-heart about what's going on right now with COVID. And they've already trusted in us to be their IoT partner as we're operating and assisting them with many parts of their operation and processes. But here's a little background about this job in general. So the purpose of the audit was to develop a scope of work to be implemented for sanitation purposes. And it's a large US-based medical device manufacturer. Now, the design of the intelligent, efficient sanitizing system incorporated with the design of the existing lighting system basically ensured our customer that not only would they have a very aesthetic approach to what we were trying to accomplish in your corporate headquarters, but we would also get a job done. And that was really important to them. And the system basically created a smart lighting system, and it has a lot of preset reporting for product usage, for energy monitoring, and for maintenance scheduling. And what we found was many of the products on the market don't have those features. As I reviewed the design with everyone, I'll talk through why those features are important and how they were used. So one of the spaces was a high bay application, and it was a multi-shift manufacturing space. The customer's concern was, wow, you know, we have this multi-shift manufacturing space where their products are kitted and assembled and put together, and there's a lot of people in a very dynamic yet compacted area. And how are they going to handle that? So we used this entail high bay, and it has a purification device, and it utilizes actually UVC and A wavelengths for sanitizing large, high ceiling areas. But we quickly realized that to be able to sanitize the space they were trying to sanitize, that the UVA just wasn't going to be enough. They did need a UVC source. There was a very high ceiling. So the use of something like an IntelliFlow trapper that we'll talk about soon really wasn't the right solution. And it did push us into a high bay category. So the fixture was equipped with 4 rotatable modules, and that's fantastic. And what those modules produce is a violet colored ambient light. That is not the UVC. But what that violet colored ambient light is, it's a beacon for the team to know if that ambient light happens to be on while you're in the space, please exit immediately because the space is undergoing sanitization. And one of the things we had to accomplish is, you know, a gold-plated pedestal within a device because it produces a more efficient dissipation of heat, sorry about that, resulting in a longer lifespan than a standard pedestal. The gold-plated UVC chip, basically it will break down viruses, bacteria, fungi, mold, spores. It does a great job for us. And it's able to be purchased with the particular optics needed to properly place that UVC and A wavelengths where it's exactly needed. So anyone who's used to running photometry, it's a very similar process until it gets a little more complex. And where the complexity comes from is not only having to ensure that the light penetrates the space that it needs to sanitize, but also that it has the adequate dosage. And that adequate dosage could mean it could be utilized by using a specific amount of fixtures, where in other cases, it's utilized by putting fixtures in the exact location needed because maybe there's obstacles in the space. And that's when you kind of feel like it's very similar to an AGI or a visual layout on steroids. When looking at the Intella orb right next to it, that's a total different scenario. So that's far UVC, and far UVC provides a lot of the same distribution breakdown of viruses and bacteria, but studies indicate that it doesn't have the same harmful effects on the human body. So the Entella orb can be tied to a sanitation lighting circuit or the standard lighting circuit. If the customer chooses to utilize LED light for ambient purposes, at this point, we're educating the customer and letting them make the decision. But more customers than not are utilizing this product during off hours for sanitation. We're also using the IntelliFlow Troffer. And I'm going to go through that in a lot of detail, showing you where it was used and how it was used. But essentially, we're doing our best to clean the air in spaces. And the IntelliFlow Troffer is a great product. But what we found is it really needs to be combined with other solutions to really give the desired effect that you're looking for. Sometimes cleaning or scrubbing the air just isn't enough. One of the things that our customer brought up to us is, when an employee enters our space, it's our goal to make sure that he's not bringing or she's not bringing illness into the facility. So their best way of doing that is by using an IntelliTemp facial recognition scanner, who actually, through facial recognition, gives them their exact temperatures. And then also pairing that with an Entella Clean portal, where when the customer enters or the employee enters the space, they actually walk through a chamber of far UVC light that effectively inactivates over 99% of the contaminants in 20 seconds. And then I heard something that was kind of, it just really focused me back on the importance of combining these systems. Is that at this point, the project was designed to a point where we feel like we covered all the bases. And then our customer says to us, but what happens when things aren't perfect and maybe that employee picks up something at the workspace? Isn't it our job to make sure he doesn't take that home to his family? And the best way to do that is for that employee to not only walk through the Entella Clean portal on the way into the facility, but also on their way out. Next slide. So through the implementation process, what we quickly uncovered is even after the specification and the engineering, after us working in CAD and in AGI 32 and visual and putting everything together and ensuring the dosages were correct, Jason earlier spoke about how are we going to make sure that this product is continually working for the customer and delivering what they need if we can't see that invisible UVC or UVA light. And I think that the answer was pretty profound when we were able to find a partner that had the capability to do energy monitoring and had a capability of understanding the time of use of each of the devices. So by having that understanding, we could quickly state that, okay, if we have to change, let's just say the UV LED light source in the IntelliFlow every 17,000 hours, we don't have to try to estimate the length of time those fixtures are actually on, but our control system provides that information to us, provides us a countdown, and potentially even sends alerts when it's time to do some maintenance on the UV light source within the IntelliFlow, within the Soul, and within the Entella Orb. What it also does is there's another metrics that helps us understand when we have to change filters within the IntelliFlow. So it put us into a position where that we understand on day one that the system's going to be efficient, and that we get reminded throughout the use of the system if there's any failures, so we could handle the maintenance work immediately. And we could also properly schedule our maintenance, know when our maintenance is due. So there's never a period of time in which the facility isn't safe. If you look at table 1, solution by area, it kind of shows that depending upon the space, there's a variance of different mixes. In some space, you'll see it's primary high bay applications, while in other spaces, we quickly find that to get the desired result that we need, that it's going to be a mix of several different fixtures and control strategies to be able to provide the customer the proper solution. Next. So here's a copy of a solution by area. You might look at this and say, wow, this looks a lot like standard photometry. And what we were able to do is understand the space, the ceiling heights, the reflectancies, all the things you would normally understand in a typical lighting audit. But then in addition to that, we were able to understand the true utilization of the space and the time that we had to properly sanitize the area during the downtimes, maybe during a lunch hour or between shifts. So with that being said, there had to be a much higher concentration of fixtures based on the downtime being highly minimized. And in addition to that, when looking at this document on the left, or the drawing on the left, you see that that's more or less a warehousing space, and that it has a fairly high concentration of fixtures. One of the other things that's under development right now is the ability to have a dual light source out of a fixture. So not just being in the position of having UVC and UVA coming out of a high bay, but having a separate driver, a total separate system that could provide regular lighting as well. We found it to be a 50-50 mix. Some of our customers state that'd be fantastic for understanding where we're at in pricing right now. You have a fixture to have basically 2 fixtures built into one, 2 totally separate drivers, 2 separate sets of controls, everything running separate out of one unit, because that's a very, very cost-effective way of doing business. However, you have other customers like this one who says, man, if we do that, then this fixture isn't going to, you're not going to be able to look up and see purple. You're not going to be able to look up and see that warning sign. And what would happen if they were in the space and the UVC light for some reason was on as well? And that was just too dangerous for them. And they felt as though 2 separate devices with 2 separate purposes was the best for them. But I've seen a mix in the industry. And we do have the safeguards and the energy monitoring in place to design the project either way. On the right side, you see a total different solution. So this solution includes some bathrooms and some office space. And these spaces have cubicles that are very tall. They are maybe a foot to 2 foot from the top of the, or from the tile in the ceiling. So when doing a layout of the orbs, what we quickly found was that we needed a higher concentration of them that you would typically find because the far UVC wasn't going to penetrate all the spaces that we needed it to. And then when you look at the IntelliFlow locations, you're going to find that it's really not typical in this application to see that as a standard lighting grid. So what we were able to do is fine-tune the LEDs to essentially have the right optics and wattage package for the IntelliFlow to act as the primary light source, as well as the air purification system. So we were able to knock out 2 problems with 1 fixture and be able to help our customer in regards to the costing on the project. So it doesn't end there, right? So we talked about the different products. We talked about the specification of the products. We talked about why we put what where. But if we were to walk away right now and the project was going to be over, the customer would have a lot on their plate to try to maintain the system. And there is a commissioning plan to ensure that it's all properly commissioned. For instance, the entail. We set a secondary safety override at 120 minutes prior to installation. We created unique Avion identifiers per fixture and location. We created failure notification and the Avion portals. We set up usage monitoring protocols and notification, and we have baseline intensity testing. With the IntelliOrb, we created unique identifiers as well. You're gonna see a lot of the same information. And looking at the IntelliFlow, you're gonna see a lot of the same information. With the IntelliClean portal, there's a baseline intensity testing. It's not stated there, but there's also a power monitoring because there's several LED arrays. And based on those arrays and their placement, we would know by wattage reduction to the unit that you would have a particular board out or you would have a problem. And then with the IntelliTemp, that's the facial recognition scanning system, taking your temperature. You could use as an employee portal. It could be as simple as and putting the employee in a position of making the right decision. It could be as complicated as attaching it to a door with an electronic lock, and it has to recognize you as an employee to be able, without a temperature and wearing a mask, to be able to send the 12 volts needed to the automated door locks to open and close the door locks, and then send push notifications or emails to the employer to notify them that maybe that's, and to link it to potentially time clocks or to link into a profile where the employer could track temperatures. And then in the unfortunate position that it comes back red and there's 102 fever or whatever the case is, at that point, an email would go to the HR that would say that the employee had a fever. And then at that point, some of our customers automatically give a free day off and require that employee to come back with a doctor's note and without a fever to re-enter the facility. And that goes back to, in the very beginning with us talking about the prevention, the mitigation, and the protection. To accomplish a lot of those goals, it's a lot more than designing the proper project and implementing it, but that's how it's commissioned and it's how the long-term service works. And that leads me, good job, Kevin, right into that service offerings. So what is the service offerings? Why do we offer them? Well, the sanitation lighting system includes a service plan that provides maintenance, operational, and data monitoring. And it really basically keeps the system functional and effective. And it provides that customer a long-term solution. I know SBT isn't, and I also know a lot of the companies on this call aren't. Companies who are looking for everything to work on day one, but come day 2 or day 3 to be able to understand, well, how do we keep this working? Now, we build everything into the front end so our customers understand exactly what it's going to take from the specification and the design to the installation, to the commissioning and to the service plans. So the frequency of full OEM manufacturer warranty support is included. Locally held safety stock to address failures. We're not going to tell you it's going to take 10 weeks to bring in a fixture to replace the fixture that you currently have. It's in a strategic location and that could potentially open you up for COVID issues. Quick response to failure replacement. Hours of use monitoring, failure monitoring, lighting general maintenance inspection. We work with an IntelliSol cleaning, where that fixture isn't essentially an HVAC unit more than a light, and it needs to be cleaned. And the HEPA rated dust removed and the filter removed. And that's a charcoal filter replacement. And in addition to that, restrooms who have IntelliFlows have a lot of value in them because of that charcoal filter. However, one of the things that we found was in restrooms, the particulate from toilet paper requires a higher level and a more frequent cleaning of those fixtures. And we have an offering that includes that regular cleaning. Intensity readings via radiometry. And IntelliTemp and IntelliClean general maintenance inspection, cleaning and sanitizing, calibration. So even though the fixture is properly calibrated on day one, there is a quarterly calibration that's really required to ensure that everything's where it needs to be. We have software updates with additional features. A lot of those features are going to surround the facial recognition and the temperature device to ensure that any additional features that are requested could be implemented. And then managing updates to employee stored profiles is also a service that could be provided.
I mean, that's really amazing, Shane. I mean, it's not as easy as just throwing a fixture up in the ceiling and saying, "Oh, I'm done with it. That's it." You know, we're protected now. You know, but it really, I think this really does showcase the capability of when you engineer a solution that is all-encompassing, uses multiple technologies, you know, IoT to lighting fixtures. I think you're able to really put together a solution that can be applied to many different applications. And that actually, you know, kind of leads me to, you know, poll number 3, where, you know, I'm interested from the audience, what are the top applications that you feel germicidal UV technology is most applicable? And I'm going to launch the poll here, so that should pop up. But I'm kind of curious on your take on this, Shane. You know, is this something that, you know, can be applied to many locations, or
Absolutely.
is it, yeah, no.
You know, I believe the answer is yes. It could be applied to many locations, but nothing's a one size fits all in regards to specification.
Right.
The quantity and different locations are going to be different. Every space is different. Just look at the density of the IntelliOrbs that were needed in one space because the cubicles had sidewalls that went 1 foot from the ceiling height, right? Mm-hmm. You look at warehouses and not being able to really utilize an IntelliFlow and have to be dependent on a high bay style application. When you look at classrooms that could use all of the things I talked about today, and there's a half a dozen more, that would be fantastic for classrooms. I'd love to talk to everybody about. I really believe that, yeah, it's all of the above and even more.
Oh, great. No, that makes total sense. You know, and with that, some responses are still coming in, but that's kind of the general sense of the poll as well. You know, about 50% say that, you know, it's pretty much good for classrooms, production areas, warehouses, you know, office spaces. You know, and there's a lot of folks that are saying, you know, offices and classrooms are really good applications of this as well. So I'll leave that poll open, but I did want to open this up to questions, and, you know, kind of, you know, don't forget, if you're in the audience, you know, submit some questions through the Q&A icon at the bottom of your screen. I do have a few questions here, and I'll just toss these out to the two of you guys just to see whoever wants to jump at it. But one of the questions is, can germicidal UVC penetrate surfaces or substances? Is that possible?
Yeah, it's a great question. So there is germicidal UV, especially when we're talking about UVC, UVA and UVB to a lesser extent, it can penetrate some surfaces and substances. It does need, again, this is why it's important that you work with a professional rather than just going on Amazon or going on a distributor website and buying a fixture. You do need to think about what type of space it's going in. If you throw a UV light product into an environment, say with art, it's not smart because the UV does do damage to paints, and it can irradiate that paint and actually wash out a lot of that color or surface texture. Glass, it doesn't. Interestingly enough, it doesn't penetrate through glass super effectively. It can actually distort the wave enough to where it's the more harmful effects of the UV light are distorted. So if you do have UVC in an area where you might be operating, again, work with your professionals, work with your architects, work with your lighting designers, work with SBT type companies, and primarily us, to help figure out where you're going to be putting it and what type of applications you're really trying to design around.
No, and I think that makes the complete sense, and I think that was a really good, example of like the art exhibit, right, or an art studio or something like that, where the overexposure of UVC, will actually deteriorate the paintings. So that is actually really important.
And actually some plastics as well. So I mean, again, if you're repeatedly exposing these things, you just need to make sure that you know what type of environment you're putting it into. Cardboard. Okay, great. You wash out the cardboard a little bit. You may lose a little bit of dexterity for prolonged exposure. Again, that's also the key, is that prolonged exposure. If it's being hit over and over and over and over again, you will have some irradiation, some degradation of the product.
Nice. I do have another question here. There's actually two questions, which I could probably put together. Can UV lights be turned on and off continuously? And the other question was, does germicidal UV lights, do they generate heat? And if so, how hot do they get? Is that true? Do they heat up? And can they be turned on and off? Because we're talking about controls and.
Yeah. So again, it definitely depends on the technology you're using. Most existing technologies from your larger manufacturers are still in the tungsten halogen. So you are talking about a lot of heat energy. Very, very little of that energy will actually be going to the production of UV light. It is slightly more effective than say a standard tungsten halogen light source, where you're really trying to pump out that white light. But you are still talking about a system that might be a 40-watt system. Probably 30% of that is going towards only light, and then the 70% is heat. So you will experience some heat increase when you're talking about those fixtures. When we're talking about LED though, and Shane, you can probably address this more effectively, but just like with standard LED, you will have a substantial reduction in heat to light ratio.
Right.
Luminaires are much more efficient and much more effective. But
it's linear. The more energy you use, the more heat that's produced.
Yeah.
No,
but again, we are talking about dramatic reduction from a tungsten source, which your signifies and your bigger producers are the legacy products, as it were, are using, as opposed to the far UV 222 to 258 LED product. And when I say that 222 to 258, that's micro nanometers, so it's just the spectral length of which we're talking about.
Okay. All right. No, makes sense. Another question just came in, this is probably a good one for you, Shane, in terms of, what does a typical installation of a germicidal UVC system look like? We did take a look at the project that you were working on, and that seemed like it's a pretty in-depth, solution. So what does that really look like? What kind of timelines are you talking about?
I'll jump right into that. So it all depends on your customer's level of comfort, and explaining to that customer exactly what the potential dangers of the product are, as well as the benefits. So I'm going to give you an example. On this particular warehouse, they've asked us to run a completely new circuit. So we're going to have a brand new circuit that controls nothing other than the UVC lighting. And then in addition to that, obviously we're doing energy monitoring, but that circuit is going to be controlled with a key. And when the key is enabled, the door locks for that area are going to be engaged. And it's an electronic function. There is a motion sensor on the inside, so anybody's trying to get out, they could still get out without a problem through the doors. But they've established, I mean, they stated that, you know, they'd like to treat it almost like emergency lighting and put it on its own circuit. Now, when you went into the other space, in the office space, they decided also to put the orbs on their own circuit. However, they felt as though there was little concern in regards to the flows, the airflow troughers. And they left that airflow trougher on the same circuit that the historical lighting was on, because as the air passes through that trougher, it gets sanitized, and the UVA and UVC has no direct exposure to the space.
Awesome.
But every customer is different. One other thing, not to say too much, but something I'm pretty excited about saying is you have those customers who are coming back to us today and they're saying, hey, you know, maybe we don't want that violet or that purple light on the bottom. But what we'll do is let's put two separate fixtures in one. Let's build on one side of the fixture with its own driver that's going to run UVC. And let's lock it out like we always had. But now on the other side of the fixture, let's use that for our everyday lighting. And it has its own driver that powers those 4 modules. So the customer's level of comfort provides a huge impact on the project design. And there's a lot of ways of doing it, as long as it's really important to have a great communication with your customer and to provide them the options so they can make the best decision for their organization.
No, what perfect timing, Shane. We just came up literally right on the hour. But yeah, I think that is really, really interesting stuff. And yeah, so I'd like to thank everybody for attending today's webinar. I'd like to thank Shane and Jason for taking the time to hop on here, talk about some of the technologies that we're working with, and to actually go through an actual use case solution that we've developed. So thank you everyone for joining. Please visit us on SBTalliance.com. We're going to have a lot of information about this particular use case and many others over time. And we will be giving a recording to this to all attendees. So thanks again for everyone for joining, and look forward to seeing you on the next webinar. Take care.
Thank you.